Okay, good morning, Victor, Billy, Chriselle, and Jan Rensis. So today we'll hope to finish, we hope to finish, at least I hope to finish, section 3.6 parts A and B, which is basically solving a non-homogeneous GLDE using the method of undetermined coefficients. Then mag-insert tayo ng isang mabilis na method, which is basically a version of the method of undetermined coefficients whenever you have a constant forcing term. All right. And then I don't know if we can start the third part of section 3.6, which is basically the method by the reduction of order. But essentially, all of these methods are designed to help us find the solutions to non-homogeneous GLDs. So ang tinitingnan natin, meron tayong operator F, which usually is little f is a polynomial. So we have a general linear differential equation in the form of the operator f of d applied to y. And then we are assuming now that it is non-homogeneous, meaning we have a non-zero forcing term. Okay? At nakita natin medyo mas mahirap isolve ito kaysa sa homogeneous GLDEs. Excuse me guys. Nawala yung nawala yung hatching. Napapahatching ako tapos biglang mawala. One of the worst feelings of all, ano? But yeah. So titingnan natin yon. Paano nagsosolve ng non-homogeneous GLDEs. Medyo nasimulan ko na yung 5 steps na kailangan natin gawin to do so. But yeah, ngayon tingnan natin paano siya gagawin with some concrete examples, all right? In section 3.2 or 3.3, we learned that if you have non-homogeneous GLDE, the solution will take the form y equals y sub c plus y sub p. And y sub c is the solution to the homogeneous equation. And ito yung ginawa natin in section 3.5. Tinignan natin yung auxiliary equation. And based on the roots of the auxiliary equation, we found the general solution to the homogeneous system or to the homogeneous equation. Now, kapag ka non-homogeneous yung GLDE, ganun pa rin. Kailangan mo pa rin isolve yung homogeneous version kasi yung general solution ng homogeneous equation ay nandito pa rin sa solution ng non-homogeneous. There's an added step, though, na kailangan tayo maghanap ng isang particular solution doon sa non-homogeneous GLDE. Now, to make it clear, all right, so tandaan nyo, ang hinahanap natin ay general solution ng GLDE. So you want a formula or a form for all the possible solution to the non-homogeneous GLDE. At ang form na yon is basically given by the general solution of the homogeneous equation plus one particular solution of the non-homogeneous system, right? So kaya posibleng iba-iba yung itsura ng ating final answers depending on what method you implement. Kasi yung pwedeng iba-iba tayo ng y sub p. Kasi yung y sub p rito, kailangan mo lang ng isang particular example ng solution ng non-homogeneous system, add it to the general solution of the homogeneous equation, then you'll get the general solution to the non-homogeneous system. Okay? Now, ito yung steps na gagawin natin. Una, isosolve nyo muna yung homogeneous version ng GLDE to get y sub c. And then second, maghahanap tayo ng homogeneous linear differential equation, preferably of the least order, na particular solution niya si R. So mag-iimbento tayo ng differential equation in the form operator G applied to D applied to Y ay equal kay 0. Ito yung ginawa natin towards the end of section 3.5 na given na sa atin yung solution, humanap tayo ng GLDE na masasatisfy nung solution na yon, right? In this particular case, ang solution natin ay CR, mag-iimbento tayo ng general linear differential equation of the form G of D applied to Y equals 0 na solution niya si R. Tapos after we got that, ang gagawin natin ay isosolve ko itong homogeneous system, homogeneous equation na to. G of D followed by F of D applied to Y equal to 0. Well, the reason behind this is, again, we know that R is a particular solution here. Okay, so ang g of d applied to y ay equal kay 0 ay merong solution na r. So ibig sabihin, from here, if we are solving this equation, so essentially we are finding a particular solution, f of d of y, f of d applied to y equals r. Kasi alam na nga natin ang g of d applied to y ay equal kay 0. So palitan mo lamang yung f of d applied to y by y, okay, we get r as our solution, right? So essentially, this is this equation in disguise, all right? Kaya gusto kong ganito yung format. And then now we will be building up ano yung itsura ng particular solution. Well, we do step number 4. Iko-compare ko yung step number 3 dun sa dun sa general solution ng homogeneous version. Then I will just cancel out those of the terms that were already in y sub c para makuha ko si y sub p. Ang reason doon ay kasi linear independent solutions yung gusto natin. So lahat ng information na nandun na sa y sub c, hindi ko na kailangang isama sa y sub p. We want y sub p to be as simple as possible. Right? So kung yung particular terms ay encapsulated na kay y sub c, tatanggalin ko na siya kay y sub p. All right? And then finally, we will substitute in yung ansatz natin para kay y sub p, papasok dun sa differential equation to find the values of the unknown parameters or coefficients. That's why this method is called the method of undetermined coefficients. All right? Now, it might hard to imagine what these steps are about without looking at a particular example. So let's jump on and look at, I think there are 2 examples here. So tingnan natin. So medyo kinip ko na yung ibang parts ng slides kasi maraming sulatin, ano. So I'll just explain step by step kung paano nakuha yung mga equations na nandyan, all right? But first we do step number 1. In step number 1, gusto muna nating isolve yung homogeneous differential equation. Kasi ito yung magbibigay sa atin ng y sub c, all right? So with that, we'll consider the GLDE, but ignore the right-hand side, the forcing term first. All right? So ito ay ang homogeneous version niya ay d squared applied to d minus 1 applied to y equal kay 0. Gawin nyo lang 0 yung right-hand side. And then solve it ala section 3.5. Okay? Our auxiliary equation is little m squared times m minus 1 equal kay 0. And the roots of the characteristic equation or the solution of the characteristic equation are 0, 0, and 1. 0 is a root of multiplicity 2. So magkakaroon tayo ng linear function c1 plus c2x times e to the 0x. But e to the 0x is just 1. That's why we simply have c1 plus c2x as our first component of the solution. All right? Tapos yung isa pa ang root ay 1, which is simple, multiplicity 1. So kapag ka meron kang root of multiplicity 1, madali lang. Meron ka lang constant times e to the root x. So here we got the root is 1. So we'll get c3 e to the 1x. So ito yung y sub c natin. Ito yung homogeneous, solution dun sa homogeneous system. So set it aside first, but at least, yay, you found half of our solution already. Because remember, the solution we're looking for is y sub c plus y sub p. So here's the bulk of the work, finding y sub p. Kasi yung y sub c, madali lang. Nagawa na natin sa section 3.5. Yung natitirang 4 na steps ay para sa pag-compute pa lamang nung particular solution. Okay, pagkuha ng particular solution. Now, this specific method will work para sa mga specific forcing terms. Kasi yung step number 2, kung matatandaan nyo, kailangan nating humanap ng GLDE, ng homogeneous GLDE, kung saan particular solution niya si R. So mag-work lang to kapag ka si R ay nasa forma ng mga na-consider natin sa section 3.5. Kasi kailangan nating mag-imbento ng GLDE na homogeneous na solution si R. So mag-rely tayo dun sa forma ng function R. Kaya hindi nag-work palagi itong method of undetermined coefficients. Mag-work lang siya para sa mga specific na R. Yung mga R's na na-encounter natin from 3.5, which basically would be polynomials, polynomial times exponentials, polynomial times exponentials times sines and cosines. Yun lang yung pwede nating paggamitan ng method of undetermined coefficient for now. Kasi yun lang yung mga kaya nating gawan ng differential equation. Okay? So in this particular case, our function r of x is 3e to the x plus sine x, the forcing term. Step number 2 requires us to find the differential equation g of d applied y equal to 0 kung saan solution niya si r. Tapos ano yung makikita natin? Well, for the first term here, the first component of the solution, ang i-imply niya si m equals 1 is a simple root of the characteristic polynomial, right? Kasi nga meron kang constant times e to the 1x. So we're working backwards now. So alam ko si m equals 1 simple root. Kaya dapat dun sa differential equation g of d applied to y, dapat meron tayong factor na d minus 1. Kasi nga dapat si 1 simple root ni characteristic polynomial g. Okay? Now, there's a multiplier here, and that multiplier will be coming from the second solution, sine x. Saan nagagaling yung solution na sine x? Well, trigonometric yan. So pwede kong i-imagine yung sine x to be constant times e to the 0x times cosine 0 times cosine x. Yung constant, lagay ko na lang sa tapat ng sines and cosines. Plus cosine to ng cosine to ng 1x plus 1 sine of 1x, right? So ito yung expanded form ng sine x. Bakit ko gustong isulat si sine x as e to the 0x times 0 plus cosine 1x plus sine of 1x para ma-reconstruct ko ano yung differential equation na sinusolve ni sine x, right? So, kasi ito yung alam natin na form mula dun sa section 3.5. Kapag complex yung root ng ating characteristic polynomial. All right? So this form tells us that a equals 0 and b equals 1. Ito yung itsura ng ating complex root. So ibig sabihin m equals 0 plus or minus 1i, which is basically plus or minus 1i is a root of our characteristic equation. So aside from 1, which is a simple root, we get a complex root, right? Para dun sa ating characteristic polynomial. So that means there is a operator d minus i and d minus minus i. So that's going to be d plus i doon sa ating differential equation. And then if I carry out this multiplication, I'll get d squared plus 1. So ito yung ating characteristic polynomial, or this is the operator, all right, na magbibigay sa atin ng GLDE na ang solution ay 3e to the x plus sine x. So we do have d minus 1 applied to d squared plus 1 applied to y must be equal to 0. Okay? And essentially, this is what we did towards the end of section 3.5. Okay lang ba to? Any questions? Can I get some reactions? Okay, good. So kaya importante, yung natitirang section ng 3.5 na hindi natin na-discuss before the midterms. Kaya binalikan ko siya last meeting. All right? Kasi kailangan natin siya sa step number 2. So essentially, our conclusion in step number 2, the forcing term is a particular solution ng d minus 1 applied to d squared plus 1 applied to y equal to 0. Now, alam na natin si g of d. Now, pupunta tayo sa step number 3. Sa step number 3, kukunin natin yung general solution ng g of d applied to f of dy ay equal kay 0. So just spell everything out. We already know g of d. This is what we invented in step number 2. F of d is the operator from the given differential equation. So ganito yung magiging itsura niya. So ito yung nanggaling sa step 2. Alright, paghahanap natin ng GLDE na ang solution ay si capital R. And this guy is from the given. Alright, ito yung f of d natin. So gagawin natin ay hanapan daw to ng general solution. But this is still fine because this is still a homogeneous GLDE. alam natin kung paano to i-solve. So just combine all of these together. All right? Tapos makikita natin, okay. So ang characteristic polynomial natin ay m minus 1 times m squared plus 1 m squared times m minus, dalawa na pala yung m minus 1, no? Magkakaroon ng m minus 1 squared. Ito yung ating characteristic equation. Tapos tingnan natin yung mga roots. Well, ito, m squared plus 1 will be equal to 0 if and only if m is equals plus or minus I. So there we know that this will correspond to what term in the solution? Kasi ito ay, ang root nito ay, baba ko na lang to. Ang root nito ay m equals plus or minus I. So a0, b is equal to 1. So we'll get c1 cosine x plus c2 sine x na manggagaling dito sa unang term, unang factor ng characteristic polynomial, right? And then plus, yung second factor ng characteristic polynomial ay m squared. So ibig sabihin si m equals 0 ay isang factor of multiplicity 2. So ibig sabihin magkakaroon tayo ng e to the 0x times 1 plus, e to the 0x, multiplicity 2 siya, so meron siyang linear multiplier, c1 plus c2x. Pero yung e to the 0x ay 1 lang, so pwede ko na siyang i-simplify. Ito yung magiging itsura niya. So ito yung solution para dito. Color coding natin siya. Para dito, ito yung nakuha natin na solution. Para dito, ito yung nakuha natin na solution. Okay. And then lastly, here, we have m equals 1 is a root of multiplicity 2. So, ibig sabihin, para dun sa huling factor ng characteristic polynomial, meron tayong solution na e to the x times, kasi multiplicity 2, so meron siyang linear multiplier. Hold on, mali pala yung subscripts ko dito. Kasi iba to dun sa constant kanina. So this is C3, C4, this should be C5 plus C6X. All right? Siguro pangalanan natin to, wag y sub, tawagin natin tong y sub t. Y sub temporary muna siya, para iba siya dun sa y na hinahanap natin na general solution. So our temporary form for the solution is this expanded format. So nag-compute lang ako ng mas malaking homogeneous GLD dito. Pinagsama ko si operator G from step 2 and the operator F from the given to get this long expression over here. Okay? So I'm not sure kung ganito rin yung ordering ng solution dun sa susunod na slide, but this is how I got this, right? I-rearrange ko lang possibly yung mga terms kay y sub t dun sa susunod na step, right? Pero ano ba yung susunod na step? Sabi ng susunod na step, okay, medyo mahaba lang. So ito yung final arrangement ni y sub t. Okay. Medyo, I think we got the same one, right? Nagkaiba-iba lang yung ordering at saka yung pag-prepare ng mga arbitrary constants, but that's fine. Now, sa susunod na step, sa step number 4, isi-simplify natin si y sub t para makuha si y sub p. Meaning, tatanggalin ko yung mga redundant information. Meron tayong y sub t, i-compare ko siya kay y sub c. Tatanggalin ko yung mga terms kay y sub t na incorporated na kay y sub c. Because we don't want to use redundant information because we want the terms in our summation, which is our solution. Gusto natin yung terms doon sa ating solutions ay linearly independent. So tatanggalin natin yung mga redundant info. So in particular, ito si y sub t natin. Kaya gusto ko may subscript t sana. Kaya lang di ko ma-edit yung slide kasi math type yung ginamit niya na pang-encode ng equations. But yeah, ito yung y sub t natin from step number 3. Ko-compare ko siya kay y sub c. Tapos tatanggalin ko yung mga redundant. Ano yung mga redundant na? Well, yung constant dito, of course, yung constant dito, just a disclaimer, Yung constant C1, C2, and C3 rito, posibleng iba sa constant C1, C2, C3 doon sa Y sub t, right? Kasi independent yung pagkakasolve natin kay Y sub little c at saka kay Y little t. So yung mga arbitrary constants dito, iba sa arbitrary constants dito. Nagkataon nga lang na dun sa pagkakasolve ni slides, hindi niya in-anticipate na magagamit ulit si C1, C2. If saka si C3. If I am solving this on paper, iibahin ko yung subscripts nito para hindi siya katulad ng mga subscripts dito. Right? So siguro tawagin natin D1, D2, D3. Just to clarify things na magkakaiba yung arbitrary constants. But anyway, makikita nyo na yung constant C1 dito ay carried over na dun sa information ng arbitrary constant dito. So in Y sub t, we can't forget about C1 pag kukunin na natin si Y sub p. Kasi incorporated na siya dun sa homogeneous solution. Kasi remember, yung final solution naman natin, y sub c plus y sub p. So itong constant na to na manggagaling kay y sub t ay naka-incorporate na dun sa D1 na naka y sub c. So there's no need to consider this any further. Pwede namang isama niyo siya, pero makikita niyo mamaya, the more terms you have in y sub t, the harder it is to solve for y sub p. Kaya as much as possible, tinatanggal ko na yung mga unnecessary information. Or essentially, those information that are already in y sub c. Tapos sa kay y sub c, meron na akong constant times x. So tatanggalin ko na kay y sub t yung constant times x. Kasi redundant info na yon. And then meron na akong constant times e to the power x kay y sub c. So tatanggalin ko na yung constant times e to the x kay y sub t to get my ansatz para kay y sub p. So my guess now for y sub p is this one. Alam ko na ang itsura ni y sub p ay c4x e to the x plus c5 cosine x plus c6 sine x. All right? And that's what we got. But remember, y sub p is a particular solution. Dapat pag pinlogin ko to dun sa aking differential operator f of d, dapat ang sagot ay si r. So we need to know the value of the coefficients c4, c5, and c6 to get the particular solution, right? And ang ginawa ni slides, pinalitan niya lang by capital letters yung mga unknown coefficients, yung mga undetermined coefficients, and that's where the name of the method came from. Yung mga unknown coefficients, capital A, capital B, capital C, must be chosen so that f of d applied to y sub b ay magiging equal kay r. Okay? Does step 4 make sense? All right, isa, dalawa yung nag-react. All right. So hopefully you guys got it. If not, any questions? Ano yung malabo? Or ayaw nyo lang mag-react button? Okay? Now, sir, bakit nga uli? Kailangan tanggalin yung mga redundant information kasi dun sa step 5. Medyo mahirap yung step 5 kasi kailangan kong palitan. Alright, si y sub p, meron tayong ansatz. Meron tayong template o meron tayong temporary guess for how y sub p looks like. Y sub p looks like a constant times x e to the x plus constant times cosine x plus constant times sine x. Now, it's time to find the value of the undetermined coefficients. How should those coefficients be chosen? They should be chosen such that f of d applied to that ansatz for y sub p ay equal kay r of x. So, kailangan i-apply ko si operator f kay y sub p, tapos i-compare siya kay r of x to get the undetermined coefficients. Okay? Gagawin ko yun. So, ito si y sub p. Ito yung ansatz natin kay y sub p. I-apply ko siya sa operator f of d. Pero ano nga yung operator f of d? This is our operator f of d. Right? So, dapat yung d squared applied to d minus 1 applied to this y sub p ay equal kay r of x para mahanap natin yung particular solution. Kasi essentially, ito yung promise ng particular solution. Si y sub p dapat ay isa dun sa mga functions na nakakasatisfy nito. Once we get our hand on y sub b or one of the y sub b's, kasi maraming posibleng y sub b's, alright? Pag nakakuha tayo ng isang y sub b, i-add ko lang to sa general solution ng homogeneous GLDE, I get the general solution for the non-homogeneous GLDE. Now we're almost done. Alam ko na yung itsura ni y sub b, but this y sub b will not work sa basta-bastang A, B, and C. A, B, and C must be chosen such that when I plug in this y sub b into the operator d squared followed by d minus 1, dapat equal siya kay r of x. Kaya ganun yung gagawin ko ngayon. Ito yung ansatz, ipa-plug in ko siya dito sa left-hand side. Right? Remember, this will require us to get what? This is d cubed minus d squared applied to y sub p, right? So which is d cubed y sub p minus d squared y sub p, which is essentially, dito na lang sa taas, y sub p triple prime minus y sub p double prime. So kukomputing ko yung third derivative ng ansatz, isa-subtract ko siya dun sa second derivative ng ansatz, tapos dapat equal siya kay 3e to the x plus sin x. And here, it makes sense that we want y sub p to be as simple as possible. Kaya dumaan tayo sa step number 4 na tinanggal ko yung mga redundant information kasi mahirap yung susunod na computation. Ipa-plug in ko yung ansatz kay y sub p dun sa f of d. Which is difficult kasi ito palang napakasimpleng f of d na to. Kailangan ko na yung third derivative ng ansatz minus the second derivative of the ansatz. So you want y sub p to be of the simplest form as possible. Okay? So let's do the heavy lifting now. Compute y sub p triple prime. Okay, right. So umpisa, compute niyo yung y prime, y sub p prime. So ito, i-differentiate natin. Kaya makita nyo na komplikado. Walang problema rito at saka rito, pero ito magpa-product rule tayo kasi meron kang constant a times x times e to the x. Product rule will kick in, we'll get those two terms. Tapos remember, kailangan natin hanggang third derivative, so computein mo si y double prime. Tapos mag-chain rule ka na naman dito, alright? So you'll get additional terms. So ito yan. Kaya kinapi-paste ko na lang yung nasa slides. You can do this by hand. So nag-second derivative lang naman ako. Tapos kailangan ko pa yung third derivative kasi nga yung y, yung f of d natin hanggang third derivative. So I'll need to compute the third derivative and take note, ito yung itsura niya. Okay? And then we'll build this together. So magkakaroon tayo ng d cubed minus d squared y sub p equals 3e to the x plus sin x. Tapos kukompute natin to. So it's going to be the third derivative, this guy, minus the second derivative. Kung ano yung sagot doon, i-equate ko siya sa 3e to the x plus sin x. Good? Now, ito yung mangyayari. Okay? Yeah. Yung third derivative minus the second derivative is this guy from our computations above. We need to simplify it because I'm going to compare it to r of x, the forcing term. Sinimplify ko, ganito yung itsura niya. After simplification, i-compare ko to doon sa right-hand side ng ating original GLDE, which is this guy. So we want this to be equal to 3e to the x plus sin x. Well, now we compare the coefficients, right? Kaya siya method of undetermined coefficient. Now, for these two equations, or for these two functions to be equal to each other, dapat term by term nag-match sila. Itong term na may e to the x, dapat mag-match dito. So I already know that a will be equal to 3 to have equality. Because if a is not equal to 3, then there's no way that these two equations will be equal to each other. Okay? And then, gusto ko, si b plus c, which is the coefficient of sin x, must be equal to the coefficient of sin x on the right-hand side. So we want b plus c to be equal to 1. All right? And then, this doesn't have a cosine term, so the coefficient that belongs to cosine x must be equal to 0. But unfortunately, that coefficient for cosine x also involves b and c. So now I should solve this simultaneous equation over here. You can solve this using elimination, substitution, or Cramer's rule. But from here, we can add the two equations together. we get 2b equals 1. So b is equal to 1/2. Right? Dahil si b ay 1/2, plug in ko siya dito sa second equation. We'll have 1/2 plus c equals 1. So c equals 1/2 as well. And those are our undetermined coefficients. So you plug this coefficients, this now found coefficients, A, B, and C, dun sa template natin kay Y sub B. Y sub B, remember, is this guy from step number 4 yata. All right. So alam na natin yung specific values ni A, B, and C, we get the particular solution. And then to assemble the final solution to the non-homogeneous GLDE, kailangan ko lang yung y equals y sub c plus y sub b. And that's the general solution to the non-homogeneous GLDE. All right. Now just assemble these pieces together. So we'll get, dami palang slides nun. Ito na siya. Ito yung y sub c natin, which is the general solution to the homogeneous GLDE. Tapos ito ay isang particular solution doon sa non-homogeneous GLDE. And when I add them together, I get all of the possible solutions to the non-homogeneous GLDE. Okay? So that's the entire process. It's quite long, all right? Pero if you are patient enough, I guess you can handle this, right? Marami nga lang steps at napaka-importante nung galing sa section 3.5. Kaya pag sa pre-final exam, pwede na kaming hindi magtanong explicitly ng isang problem na homogeneous. Kasi sa pagsasolve ng non-homogeneous, ilang beses kayo magsasolve, at least twice kayo magsasolve ng isang homogeneous GLDE. Okay? All right, I'll give you 30 seconds to digest these things up. Then let's consider one more example. All right, so 30-second break. 30-minute break, 30-second break. Oh, by the way, guys, I just started grading your work, your midterm exam. Siguro nakaka-apat pa lang ako na, or 4 or 5 na number 1B. 1B pa lang yung sinisimulan kong checkan. Nakapag-check siguro ako ng mga 5 papers. So that means medyo marami-rami pa. Plus yung Math 174. Ako rin na nag-check ng lahat ng problem set ng 174. So I hope you'll be patient in waiting for the results of the midterm exam. Give me probably 1 or 2 weeks to finish it, right? Medyo mahina yung kalaban and I really read everything, right? Tapos binrowse ko yung ibang mga videos, yung mga solution videos nyo. Medyo mahaba, mga 4 to 6 minutes bawat video. So yeah, it will take some time for me to finish grading it. But I hope you understand. So chill lang, guys. So I'll do it whenever I have extra time. What else? Yeah, we have a homework. Remember, I want you to have a reaction video on the midterm exam. Meron na siyang submission bin kay Canvas. Double check the deadline. I guess the deadline is Wednesday, 11:59 p.m. So kindly take note of that. It doesn't have to be long. It doesn't have to be formal. All right. Pwede siyang video, pwedeng podcast style. So 1 to 2 or 3 minutes, that would be perfect. So it could be informal. And your honest reaction, it would be appreciated para alam ko yung magiging adjustment sa pre-final exam. So yeah. Okay, back to regular programming. Let's look at another example. So let's have d squared plus d applied to y equals negative cosine x. First step in the solution. I'm thinking, cross ko lang, guys, kasi hindi ko tanda kung, yeah. So freestyle ko to isa-solve. All right. Wala pala ako kinopy-paste mula dun sa equation sa handout. So let's do this step by step. So step number 1, we need to find bullets ko sige na. Tulad ko na step 1. But you don't have to specify the steps, ano? So, para lang maganda yung discussion, pakita ko siya step by step. But you can organize your solution in any way you want, right? So, in step number 1, we first solve for y sub c, which is the solution for the homogeneous version of the differential equation. Okay, so gusto nating i-solve yung d squared plus d applied to y sub c equal to 0, the homogeneous equation. Now note that the characteristic equation for, let's call this equation star, okay, is m squared plus m equal to 0. Note, kapag ka equation yung binigay ko, tinatawag ko siyang characteristic equation. Kapag ka m squared plus m lang yung ginagamit ko dun sa sentence ko, ang tawag ko ay characteristic polynomial. So make sure you draw the distinction between those two, right? So ito yung characteristic equation ko. Pwede ko itong isulat na m times m plus 1 equal to 0. Okay? So that means we get simple solutions, right? So that means m equals 0 and m equals -1 are simple roots or simple solutions. Wala ang multiplicity nila parehas ay 1. So from here, we know that y sub c will be constant c1 e to the 0x. That is the solution corresponding to the simple solution m equals 0. But I can just simplify that to 1 plus c2 e to the -x. So that's our y sub c. Papayin ko lang to. Right? Para alam ko siya mamaya. Alright, yan yung ating homogeneous solution. Okay, good. So step number 2 is to find the GLDE. We need to find the differential operator g of d such that g of d applied to negative cosine x ay equal kay 0. Gusto kong makahanap ngayon ng general linear differential equation characterized by the operator g of d na solution niya si r of x. So mag-iimbento ako ngayon ng GLDE na solution niya si negative cosine x, right? Now, so note that si negative cosine x, pwede ko siyang isulat na -1 times e to the 0x times, baliktad pala, but lagi ko dun siyang kinakabit. Ganito na lang, e to the 0x times -1 cosine ng 1x plus 0 times sine ng 1x. I'm writing it this way kasi ito yung alam natin na solution mula dun sa section 3.5, alright, na nag-i-involve ng sine and cosine. Right? So once I have it in this form, I know that a equals 0 and b equals 1 makes m equals a plus or minus bi a solution or a root to the characteristic polynomial. All right? So sinulat ko si negative cosine x kasi ito yung gusto kong solution. Isulat ko siya sa format ng mga solution na may cosine mula dun sa section 3.5. Nakita natin yun yung e to the ax times constant times cosine bx plus constant sine bx. So that means negative cosine x is of that form where a is equal to 0 and b is equal to 1 and your arbitrary constants for the cosine and sine are -1 and 0 respectively. So ang sinasabi niya sa atin, si a plus or minus bi, which in this case is plus or minus I, is a solution, is a root to the characteristic polynomial. All right? So that means this m, which is plus or minus I, is a root to the characteristic polynomial. So that makes our characteristic polynomial is m minus I times m minus I. It's m plus I. So this is m squared plus 1. So therefore, ang ating G applied to D ay equal kay D squared plus 1. Ito yung operator na kailangan nating gamitin sa pagbuo ng GLDE kung saan yung solution na makukuha na kung saan yung GLDE na yon ay may solution na negative cosine X. Okay? Do you agree with the analysis that we have so far? Sabihan niyo ako kapag may mali kasi mahaba-haba ito, 5 steps. So pag nagkamali ako sa step 2, babalikan ko na naman siya pag na-discover natin na mali ako sa step 3. Right? Okay, so ngayon, step 3 na tayo. Sa step 3, kailangan kong hanapin yung general solution ng G of D applied to F of D applied to Y equal kay 0. Okay? So yun yung gusto natin gawin. So ano yung G of D applied to F of D applied to Y? So magkakaroon tayo ng G of D ay D squared plus 1. This is what just we got, mainit-init pa, times D squared plus D. D squared plus D siya si F. Tapos yun yung ating G. So I'll just copy this over. Pasensya na, meron akong memory of a goldfish. So kailangan kong i-copy ito dun sa susunod na slide. Okay, so we want to solve this. Okay, so or actually y sub t yung hinahanap pa natin dito. So iso-solve ko yung G of D applied to F of D, y sub t ay equal kay 0. Ito yung step number 3. Hanapin ko yung general solution nitong GLDE na to. Well, the good thing about this is wala naman akong pwedeng i-combine. So ibig sabihin here, the characteristic polynomial has roots plus or minus I. Yan ang galing dito. At saka para dito sa isa na to, nakita na natin yan before, right? Nakita na natin yan ay 0 and 1. Yan yung 4 na roots ng ating bagong characteristic polynomial, which is basically a repetition of what we have earlier, right? So ibig sabihin si y sub t natin ay gamit ako ng ibang variable. Sige. Ano yung variables natin ginamit hanggang ano yung arbitrary constants hanggang C2, no? Simulan ko to sa C3. Now, meron akong cosine IX. So, meron ako dapat ditong C3 cosine ng X plus C4 ng sine X. Yan yung solution sa nanggagaling sa plus or minus I. Tapos, yung manggagaling sa 0 ay C5 e to the 0x, but that is just 1, plus C6 e to the, sorry, negative 1 pala to, no? So e to the negative x. Okay? Ito yung ating y sub t. Tapos sa step 4, i-compare ko si y sub t kay y sub c. Tapos tatanggalin ko lahat ng information na kay y sub c na mula kay y sub t para makuha si y sub p o yung ansatz para kay y sub p. But remember, this is our y sub c. Gusto ko munang i-simplify yung gagamitin ko sa step number 5. Alright? Kasi masyadong komplikado kapag ginamit ko yung buong y sub t. Note, ito si y sub c. So kay y sub c, andon na yung constant. So tatanggalin ko na tong constant na to. Tapos andito na rin yung C2 times e to the negative x. So meron ng arbitrary constant e to the minus x. Tatanggalin ko na to. So ibig sabihin ng ating y sub p na lamang ay dalawang terms. Yung a cosine x plus b sine x. And for this particular example, we do have two undetermined coefficients, capital A and capital B. Now, kung ayaw nyo nang dumaan sa step 4, I think pwede pa rin. Kaya lang, I imagine the additional work of finding the derivatives of this guy. Alright? So medyo mahaba-haba yung proseso kung gagawin niyo yun. So ito na lamang yung ating template para kay y sub p. Kasi isang particular solution lang naman yung hinahanap natin eh. So kapag ka ito i-consider nyo pa kay y sub p, okay lang din naman. You get a different or you might get a different particular solution y sub p, but that's fine. Kasi ang usapan lang naman natin, solution sa homogeneous plus isang particular solution dun sa non-homogeneous. Yun yung general solution dun sa non-homogeneous GLDE. Okay? Now, I think we're ready for step number 5. But is everything okay? Meron ba akong bubu na ginawa? Hopefully, tama pa rin so far. Wala nag-agree. Hopefully, tama pa. Thank you. So, yeah. Punta tayo sa step 5. So, step 5, isosolve na natin yung undetermined coefficients. So, gusto ko yung f of d applied to our ansatz y sub p must be equal to r of x. And then we will compare the coefficients. All right? Now, what do we want to happen? Ano nga si f of d? Si f of d ay d squared plus d applied to y sub p must be equal to r of x. But r of x is equal to, what's r of x? Negative cosine x. R of x is the right-hand side here, the forcing term. Medyo i-rearrange ko lang para medyo maganda yung solution natin. Dito ko siya ilagay. Negative cosine x equals this guy applied to our ansatz for y sub p. But remember, our ansatz for y sub p is a cosine x plus b sine x. All right? So, kailangan ko ngayon itong i-simplify. Okay? Now, this means maging equal to sa ito ay i-apply ko rito. Second derivative ng a cosine x plus b sine x. Well, ang first derivative niya, ang first derivative ng y sub p, dito na lang sa scratch paper ko gagawin. So si y sub p prime ay equal kay negative a sine x plus b cosine x. And then y sub p double prime ay equal kay negative a cosine x minus b sine x. Or siguro sama ko na siya sa solution. Sabihin ko lang na note that meron tayong dalawang derivatives na to. Period. Then, we'll know this. Si negative cosine x dapat ay equal kay second derivative. So we'll have negative a cosine x minus b sine x. Because here I have second derivative applied to this guy plus first derivative applied to that guy, but we already computed that before. So we'll have minus a sine x plus b cosine x. Okay? Tapos isi-simplify ko ngayon. I will simplify the right-hand side of my equation so far so that it is easy to compare coefficients. Ang meron tayo dun sa right-hand side, dun sa forcing term, ay may cosine. So ang gagawin ko, lahat ng may cosine, pagsasama-samahin ko. Tapos lahat ng may sine, pagsasama-samahin ko rin in another group. So essentially, I can write the right-hand side as what? I'll have b minus a, or huwag ko nang palitan yung order. I'll have negative a plus b times cosine x plus negative b minus a sine x. Or pagbaligtarin ko to para madaling mag-elimination mamaya. So it's going to be negative a minus b times sine x. So what's the equations now for the undetermined coefficients? We want negative a plus b to be equal to negative 1, which is the coefficient of cosine on the left side. And we want this guy, negative a minus b, to be equal to 0. Alright? Tama ba? Sulat ko na lang siya muna rito. Kasi nga, next page na ako. So I'll have negative a plus b. Gusto ko equal kay negative 1. Tapos ang negative a minus b gusto ko ay equal kay 0. Okay? Tama ba yun? Before I go to the next step? Okay? All right. So from there, from this, we obtain the following system. Tapos pwede kong i-add yung dalawang equations together, right? Or yung corresponding sides ng dalawang equation ito. I'll get negative 2a equals negative 1. That means a is equal to 1/2. And then if a is equal to 1/2, then we'll have negative 1/2 plus b equal kay negative 1. So that means b is equal to negative 1/2. All right. So therefore, our general solution for the non-homogeneous GLDE is y equals y sub c plus y sub b, but our y sub c is this guy. Ba't ko pa sinulat? Ito na pala yun, ano? So I'll have this y sub c that we set aside from step number 1 plus, remember our ansatz is for y sub p. Y sub p is a cosine x. Our a is 1/2 times cosine x. There we go. And then plus b sine x. Our b is negative 1/2. So we get that. Luckily, tama yung sagot natin. All right. So, oops. This is our general solution to the non-homogeneous GLD. Okay? So essentially what's new here? Steps number 2 to step number 5. All right? Steps number 2 to step number 5. Step number 2 to step number 5. Ano? Ang trabaho ng pagko-compute ng y sub p, which is a particular solution to the non-homogeneous GLDE. Okay. Pero yun nga, napakalimitado nitong method of undetermined coefficients because the entire thing rests upon step number 2. Kailangan makapag-imbento ka ng operator g of d for which g of d applied to r is equal to 0. Dapat makapag-imbento ka ng homogeneous GLDE na solution niya si r. And napaka-restricted yung mga forma natin para dun sa g of d. Alright? So kaya lang natin siyang gawin kapag ka si r ay polynomials, exponentials, and then sums of sines and cosines, and linear combinations thereof. Aside from that, hanap kayo ng ibang method. Or i-derive nyo kung paano, or pag-aralan nyo kung paano humanap ng g of d para sa mga functions of a different form. But that will be a tedious job. That is a complicated and hard job for very complicated right-hand sides. Okay? So hopefully nakikita nyo yung limitation nitong method na to. But this is one nice method. Ano? Mahaba lang, pero you'll get there if you're patient enough. Okay? Now let's see. Do I have another example? Oh no. So you can practice one of these two equations over here. Kaya nyo pa ba mag-isa pang homework? Homework 10 na tayo? Kaya pa? Or wag na muna? Bakit walang sumasagot? Sige, homework ko na to para masanay kayo, mapwersa kayong mag-practice because this is a methods class, ano? Methods class to, and in math, you don't learn math if you don't get your hands dirty, ano? So to learn math, you have to go into the mud and play with the different different problems, right? So you need to struggle a little bit to learn kung ano yung mga pinakamadaling paraan para matutunan nyo yung mga methods. Ano? So, yeah, let's do this as homework number 10. Pero gawin nating deadline ay at least 1 week tayo dapat, no? So, dapat November 25. Oh, ang bilis. Magdi-December na. So, pero gawin nating December... sorry, not December. Gawin nating June ng November 29, 11:59 p.m. Ito yung Tuesday. So yung hating gabi bago tayo magklase week after next. Ano? So, kasi nga 1 week yung at least para sa homeworks natin, pero dagdagan natin ng konting panahon. So, yeah, Tuesday na lang, right before midnight. Okay? Pero please start doing it as early as you can para hindi kayo natatambakan. Ano? So, pili lang kayo ng isa. Choose one. Siyempre, pipiliin nyo yung number 1 kasi mas simple siya, ano. But if you want to make pasikat, edi try number 2, ano. So, yeah. Okay, so, yeah, section B. Siguro, yeah, kaya pa natin itong tapusin. Now, nakita nyo, dun sa section A, sa part A ng section na to, yung solution by the method of undetermined coefficients, meron tayong step 2 to step 5, which strives to find the particular solution. Now, nag-work siya kapag si R ay nandun sa mga forma na binanggit ko kanina. Pero may special case. Special case kapag si R ay constant. Okay? So kapag si R ay constant, mas madaling kumuha ng Y sub P. Pwede mo pa rin naman gawin yung step 1 to step, yung step 2 to step 5 ng method of undetermined coefficient, but there's an easier way to do it. And that is by inspection. Right? Kasi nag-work to kapag si R sub 0 ay constant. But it is broken down to 2 cases. Unang case kapag si Bn ay hindi equal kay 0. So ibig sabihin, meron kang mga derivatives dyan, tapos meron kang constant times y. The constant Bn is not equal to 0, equal siya kay constant R sub 0. Okay, palitan natin to. Ang assumption kasi dito si R of x ay constant, so dapat siya ay R sub 0. O si R sub 0 ay constant. Now, if I will just choose y sub p, so kung si Bn ay constant, ang hula ko para kay y, si y dapat ay isang constant. And then I can determine what that constant is para makakuha ng isang particular solution. Alright? Paano siya nag-work? Kasi kung alam ko na si y ay constant, yun yung ansatz ko, yun yung hula ko para dun sa particular y sub p. Alright? Siguro tawagin natin itong y sub p. So, ang hula ko kay y sub p ay constant. Bakit ko na-realize by inspection na si y sub p ay pwedeng isang constant? Well, we can work backwards. Kapag si y sub p ay constant, so itong derivative na to ay 0, itong derivative na to ay 0 kasi nga si y ay constant, matitira lamang itong term na to. Ang b sub n times y ay equal dapat kay r sub 0. Pero what should y be? Y is a constant such that when I multiply it by b sub n, ang sagot ay si r sub 0. The only logical answer to that is solve this equation. B sub n times y sub p equals a constant r sub 0. So that means the particular solution or a particular solution is r sub 0 over b sub n. But again, this is provided that b sub n is not equal to 0. And hence, kaya nakuha yung particular solution na yan. Right? Which makes sense kasi kung si y sub p ay constant na r0 over bn, itong derivative na to ay 0, ito ay 0, lahat ng derivatives actually ay 0, matitira lang si bn times our y sub p, which is r sub 0 over b sub n, maka-cancel yung b sub n, r of 0 lang ang matitira, which is our right-hand side. So, madali kapag constant yung particular solution. Pag constant yung forcing term. Tapos meron kang term na constant times y. Okay? So, makukuha nyo yung particular solution ng mabilis. Kailangan nyo na lang yung solution sa homogeneous system para makuha yung general solution dito sa equation star. Okay? Siguro, let's illustrate this via one example. So, halimbawa, ito yung GLDE natin, yung non-homogeneous GLDE. D squared plus 4 applied to y is equal to 12. So, punta pa rin ako dun sa step 1. Isa-solve ko yung homogeneous differential equation. So, I look for the solution. So, I'll solve d squared plus 4 applied to y equal kay 0. Kasi kailangan ko pa rin yung homogeneous solution. Well, I know here that m equals plus or minus 2i is a solution of the characteristic equation. Okay? Kasi ang characteristic equation natin ay y squared plus 4 equal kay 0. So that means m squared equals negative 4. That means m equals plus or minus 2i. So kung yan yung ating roots doon sa ating homogeneous GLDE, so that means ang A natin ay 0, ang B natin ay 2. So that means ang ating homogeneous solution ay constant C1. Sorry, wag na yung constant muna. E to the 0x times constant times cosine ng 2x plus constant times sine ng 2x. All right? Tapos you can forget about e to the 0x because that is just equal to 1. So ito na lang yung ating y sub c. Okay? And then kailangan nating kumuha ng isang particular solution dito sa GLDE na yan. Non-homogeneous GLDE na yan. You can carry out steps number 2 to step number 5 that you learned from the method of undetermined coefficients. But you know that's a very long process. Pwede natin gawin yung by inspection. So here, alam ko si b sub n, which is the last term, equals siya kay 4. Alright? So essentially, dahil constant yung forcing term, magkikick in yung case 1 ng section B. So ibig sabihin, y sub b would be r sub 0 over 4 particular solution C3. Bakit sure ako na C3 ay isang particular solution? Una, kasi yung right-hand side ay constant. Alright? And then y sub p is a constant, so d squared applied to y will be 0. So matitira lang ay 4 times y, dapat equal kay 12. So that means y should be equal to 3. So nakakuha ka na ng particular solution. Therefore, the general solution to the GLDE, to the non-homogeneous GLDE, is y equals C1 sine ng 2x plus C2 cosine ng 2x, which is our y sub c, plus the particular solution 3. All right? And then you can check. I-plug in nyo ito dito sa d squared plus 4 applied to y, dapat 12 yung makukuha nyo. And understandably so. Kasi pag itong first two term, sinobject nyo dun sa operator, ang sagot ay 0, plus si 3 is subject nyo sa operator and sagot ay 12, which is exactly your right-hand side. Okay? All good? Sana ganito na lamang palagi. Constant yung right-hand side. Pero of course, sa exam, hindi ganon. Alam nyo na, terorista kasi yung mga prof nyo. So yung right-hand side, hindi namin gagawing constant. Kasi madali lang kapag constant yung right-hand side. So yeah. But of course, this is one special case of the method of undetermined coefficients. If you hate memorization like me, you can just study method of undetermined coefficient and apply it to this. Pero you see the convenience of knowing that by inspection, if the right-hand side is a constant, I know that the particular constant is another constant. The particular solution to the non-homogeneous GLD is another constant. Okay? So try to answer the other problem. Okay? So yeah. Binigay naman dito, double check nyo na ang particular solution ay -2. So all that's left to be done is to compute for y sub c and then add y sub c and y sub p to get the general solution. Okay? But this is just case 1, the case that you have a non-zero b sub n, meaning non-zero yung multiplier kay y. So dito 4 yan, ito ay -3. Paano kapag walang constant term dun sa operator? Ibig sabihin, hindi na lang pwedeng basta-basta constant yung ating hindi na lang basta-basta constant yung ating y sub p. All right? Now that's taken care of case number 2. And this is more general because this allows the coefficient of our operator to be non-constants, right? So ang i-assume lang natin, dun sa ating non-homogeneous GLDE, merong kang function of x times the nth derivative plus another function of x times the n minus first derivative, and so on hanggang b sub n of x times d upper k, all right, applied to y ay equal kay 0, where k is not equal to 0. Ibig sabihin, wala kang constant times y. Kasi kung may constant times y ka, sa case number 1 ka papasok. So ibig sabihin, meron kang derivative palagi na naka-attach kay y. So ibig sabihin, si y sub p, hindi na lang siya basta-basta pwedeng maging constant. Okay? Pero ganun pa rin yung gusto kong mangyari. Gusto ko equal kay constant etong expression na yan. Well, one trick, kasi nga isang particular solution lamang yung aking kailangan para makuha yung general solution. So I can make up a particular ansatz for y sub p. Paano ko yung gagawin? Well, gagawin ko lang ay gusto ko magzi-zero yung higher order derivatives. Para pag itong y na to, if the degree of y is small enough, alright? Kung small enough yung degree ni y, na pag pinasok ko siya dito sa nth derivative, dapat magzi-zero yung derivative. Ganun din, gusto ko rin mag-zero yung n minus first derivative. Hanggang doon sa k minus 1 derivative. Gusto ko isang derivative lang yung matira. So at the end of the day, I want d sub n applied to y, or sorry, d sub k plus 1 hanggang d sub n, d upper n applied to y ay equal kay 0. Para lang mas simple, para ito na lang yung matitira. Oops, sorry. Gusto ko ito na lang yung matitira. So I will choose the degree of y wisely. I'll assume that it's a polynomial. It's a polynomial of the appropriate degree para yung k plus first derivative hanggang kay nth derivative ay magzi-zero para madaling mag-solve ng particular solution. Alright? Now, what is that degree? Gusto ko lang matira ay ang gusto ko lang matira ay order k na derivative. Gusto ko mula sa k plus first derivative hanggang nth derivative ay magiging equal kay 0. So dapat ang degree ni y ay k. Right? Kasi ang k plus first derivative ng polynomial of degree k ay equal kay 0. So that's why makikita nyo dito, yung y sub p natin may x to the power k. Just to guarantee that the derivative will be equal to 0, starting from order k plus 1 hanggang order n. Tapos, so kapag alam ko na si y sub p, ang itsura niya ay unknown function a times x to the k. Ito yung answer, ito yung hula natin. Ito yung ansatz ko para kay y sub p. So pag ito, in-apply ko sa nth derivative, magzi-zero. In-apply ko to sa n minus 1 derivative, magzi-zero. So, magzi-zero lahat ng derivatives except for this one. So, magkakaroon ako ngayon ng d sub n minus k of x, d upper k, applied to a times x to the k, gusto ko itong mag-equal kay r sub 0. So, ang gagawin ko lang, i-divide ko both sides by this function. Alright? So, palaking ko ng konti. So, i-divide ko lang both sides by this guy para ito mapunta sa denominator. Okay. So, ang gusto ko ngayon mangyari, si d of k, alright, ang derivative niya ay dapat maging equal dito. Okay. However, itong x to the power k, alam ko ang derivative niya ay magkakaroon ng k factorial. Right? So kaya meron kang k factorial sa ilalim, tapos itong b sub n minus k nandun sa ibaba. Right? So kasi nga ito ay magiging a, yeah, this will tell us that a should be k factorial. para magsasakto yung mga derivatives. So essentially, what our formula for y sub p would be this. Yung constant forcing term times x to the k, where k is the smallest order non-derivative, divided by whatever the coefficient of that lowest order derivative is times k factorial. Ma-double check nyo yan pag pinalitan nyo ito, pag ito, in-apply nyo dito sa operator na yan, ang sagot ay r sub 0 lamang. Okay? So let's see this in action. Okay? Tingnan natin to. Obtain, hindi particular solution yung hanapin ko. General solution yung hanapin ko para kompletong example yung gagawin natin. So I want to obtain the general solution. So hindi dapat the. Obtain the general solution for the following GLDEs. So d cubed plus 5d applied to y equals 15. Look at the forcing term. The forcing term is 15. So papasok siya sa section B. Of course, you could have used the method of undetermined coefficient here, but that's quite an overkill. So what I'm going to do is, just appeal to method B, solution by inspection, right? So alam ko constant si forcing term. Tapos meron akong derivative dito of order 1. Sayang. Kasi kung may plus constant dyan, alam ko ang y sub p ay r sub 0 over whatever that constant is. Kaya lang, hindi lang constant. Meron derivative dito nakasali. Alright? Let's take care of that later. Let's start first with the easier one or the more familiar one, solving the homogeneous GLDE. So note that the characteristic polynomial for the homogeneous version of the equation is m cubed plus 5m. Yan yung homogeneous, yan yung characteristic polynomial, which we can write as m squared, m times m squared plus 5. Okay. With roots, actually not just roots, pero alam ko simple roots to. Ang simple roots niya ay m equals 0 and m equals plus or minus 5i. Sorry, not 5i. Root ng 5i. Tama ba? Yan yung mga roots ng ating characteristic polynomial. Yes. So therefore, our y sub c would be constant c1 e to the 0x para dito kay m equals 0, but e to the x is just 1, so let's forget about that. Plus, yung manggagaling naman dito, so it's e to the 0x then times arbitrary constant times cosine ng square root of 5x plus constant sine ng square root of 5 times x. Yan yung ating y sub c. Okay? Now, to complete the solution, we need a particular solution for the non-homogeneous GLDE. Now, from case number 2 nung section B, meron tayo rito, ang k natin dito ay 1. Kasi 1 yung lowest order non-derivative. So therefore, we'll get y sub p equals, tama ba? R sub 0. Yes, R sub 0 siya. So R sub 0, so magkakaroon ng 15 x to the first power, kasi first derivative yung natira, so ang k natin ay 1. So x to the k, first power of x, divided by whatever the coefficient of the first derivative is. That's going to be 5 times k factorial. Our k is 1, so I'll have a 1 factorial here, so it's going to be 3x. Not 3x. Hindi, tama, 3x. You can double check bakit 3x. Well, plug in 3x into your y here. Third derivative ni 3x, that's gonna be 0. Tapos first derivative ni 3x ay 3. So first derivative ni 3x ay 3. So we'll have 5 times 3 equal kay 15. Indeed, 3x is a particular solution. Nakita niyo yung reverse engineering para ma-compute yung particular solution. Now, once you have that, we now can complete our solution. Add ko lang yung y sub c at saka yung y sub p. We get this. So conclusion, or kinapi-paste ko ba? Or hindi ko siya kinapi-paste. So therefore, the general solution is y equals y sub c plus 3x. End of solution. All right, napagod ako doon. Any questions? I hope it's okay. All right. Hindi ko nasisimulan yung section 3. Yung susunod na section, part C na, or section C ng section 3.6. Yun naman ay, ano ang title nun? Reduction of order. Yung susunod na method ay kapag ka second degree yung non-homogeneous GLDE or second order yung non-homogeneous GLDE, but that will apply kasi pwede mo siyang gawin repetitively. All right? But that's a lot of substitution. The idea in the next section is meron tayong order 2 na GLDE. I will do the appropriate substitutions para yung second order na yon ay maging first order lamang. Tapos pag first order na siya, kaya na natin siyang isolve using integrating factor. Right? Pero gawin natin yan on Wednesday na lamang. Okay? All right, so I'll end here. Himala, 3 minutes beyond, 3 minutes before the dismissal time. But I hope you guys learned something new today. All right. Reminder, meron tayong homework number 9, which will be due, I think, this coming Wednesday, 11:59 p.m. And then we have homework number 10, which will be due on the 28th, I think, 28th, Tuesday, week after next. Di pala Tuesday. Hold on. Kailan ko siya nilagay? Dapat November... Yeah, November 29. That's Tuesday, week after next. Right before midnight as well. Dami na nating homework, 10 na, no? Pero at least bite-size siya, no? Hindi siya yung mahabang problem set tapos meron pang pre-fi exam. Pero the purpose of that is for you to be forced to solve some problems. Kasi nga, baka sa pre-fi, face-to-face na tayo. So, wala kayong cheat sheet na pwedeng gamitin. Ano? So, kailangan tandaan nyo yung mga methods, tandaan nyo yung mga nitty-gritty ng mga solutions, at saka yung mga derivatives, saka integration formulas. All right? So, let's end it here. So, enjoy the rest of the day, guys. Enjoy the weekend. Hopefully, you find time to relax over the weekend. Kasi mapapasabak na naman kayo kasi week 12 na next week. And I know academic requirements will start piling up. Dumarami na rin ang mga dapat namin checkan. So pare-parehas tayo nga sa Hell Week na, no? Kasi we're in the long stretch na of the semester. But thank you guys for coming. Kita-kits Wednesday, right? Bye, guys.